So the last section for this unit gets into solving application problems with two unknown quantities. So we had looked at just one unknown in the previous section. So now there's a lot of similarities. So the steps are going to be exactly the same. So you don't have any new steps. There's still those 6 steps from the previous section. But there is a tip. In general, when setting up your variables, determine which of the two quantities you need to know first, and that can be your x. From there, you should be able to write another expression for the other quantity using x. So again, two things that are going to be linked to each other. So let's take a look at the first one. My sister is 9 years older than my brother. The sum of their ages is 51. Find their ages. Now, you got two things that you're trying to find out. You got your sister and your brother. But now one of those can be determined once you know what the other one is. So you have to determine what that first thing is before you can figure out the other thing. So which of those two is it? Do you need to know your sister first, or do you need to know your brother first based on the way this is worded? And once you determine that, that's your x. So you can let x equal that first thing. And if you're struggling, you're going to have to know what the brother is. The brother's age is going to have to be first because the sister is 9 years older than the brother. So once you know the brother's age, then you can figure out the sister's age because it's 9 years more. So we'll call x the brother's age. And so now if we want to describe the sister's age, 9 years older, more than your brother. Now remember, we can rewrite it as x plus 9 because addition is commutative. So that gets our descriptions in place for our expressions. And now we got to put it into an equation. So it says the sum of their ages is 51. Now a common mistake people make is they'll say, oh, okay, x plus 9 equals 51. Well, there's a problem with that because you're only including the sister's age. Sorry about that. So you're saying the sister's age is equal to 51 because that's x plus 9. If you want the sum of their ages, you have to add the brother's age and the sister's age together. So it's going to be x plus 9 equals 51. Now we have both of their ages. So there's the brother, there's the sister. So now we can combine. So the x's will combine nicely, and then we can subtract the 9. So we get 2x equals 42, and then divide to get x equals 21. Now, be careful. These are word problems. Don't just write x equals 21 and move on to the next one. You got to answer the question. It wants the ages of your siblings. So you have to put that back in to see what those are. So that's why I like these let statements, because then you can just say, well, this is equal to, well, x is 21, so 21 years, not odd, but old. Maybe your brother's odd, who knows. And then if we plug it in here, 21 plus 9 is 30. So 30 years old for your sister. And we can see that it checks. If we add those up, we get our 51. So we're in good shape. All right, let's try the next one. Jason paid 5 times as much for his computer as he did for his printer. He paid a total of $1,320 for both items. What did each item cost? Well, we got to set up our x's. So the question is, what's x? We got those two things. We got the computer and we got the printer. So which of those do you need to know first in order to figure out the other one? He paid 5 times as much for his computer as he did for his printer. So you really need to know what the printer was first because it's 5 times as much for the computer. And so 5 times as much should be 5x. So there's our two expressions. And so now he paid a total of $13.20 for both. A total. Add. We got to add those together. So x plus 5x equals 13.20. So 6x equals 13.20. And then divide by 6. So x equals 220. So the printer would cost $220, and the computer would be 5 times that, so that's going to be $1,100. And again, if we add those up, we get our 1320. All right. So far, so good, hopefully. Let's try one more, and then we'll break till the next video. So in the U.S. Congress, the number of representatives is 65 less than 5 times the number of senators. There are a total of 535 members of Congress. Find the number of senators and the number of representatives. Okay, so same as before. Let x equal one of those two things. Do we want x to be the representatives, or do we want x to be the senators? So which one should be our x? Representatives is 65 less than 5 times the number of senators. So we really got to know the senators first, and then we should be able to figure out the representatives. Okay, I'm going to be lazy and just write reps. And so now how do we write it? Be careful. 65 less than 5 times the number of senators. So what do you think? 65 minus 5x? No. Remember, less than is subtraction, but it's reversed. So the 5x has got to go first minus the 65. So 5x minus 65. All right. So we got both of those two groups identified. And so now the total is 535. Only senators and representatives are in Congress. So we have to add up both of those together. So 535. All right. Combine our x's to 6x. Add the 65. And then divide. Now I know I might be going a little fast, but just remember, once you get x all on one side, once you've simplified obviously first and combine those like terms, make sure you get rid of all the stuff that's attached to the x. You always start with stuff that's added and subtracted first, and then you get rid of stuff that's multiplied onto it last. And that will get you to your x. So now, we got 100 senators and how many representatives? Well, we got to plug the 100 in. So 5 times 100 is 500 minus 65. It's going to be 435 reps. And we can see that adds to the 535. All right, so let's stop there, and then we'll pick up more in the next video. See you soon.